From SEPS, it's possible to export a data file as a BIM Excel file that can be used by the design teams to work on projects. Setting up a project in SEPS and then going to the reporting function, there are options to select that allow a project BIM export in Excel format. This is an Excel file that creates a building information modeling file for the design teams. Select Project BIM Excel Export File. Export the Excel file. This can now be used by some BIM applications to create 3D BIM of spaces and equipment. Decision making for healthcare planning of spaces and equipment using SEPS and BIM. As is shown in the introduction to SEPS and BIM from VA, subject matter experts, clinicians, VA, and consultants spend thousands of hours collecting information and knowledge into documents like this for department update of spaces and equipment. The status quo is a manual process using hand sketching to capture decisions. This is prone to error. Now with a connection from SEPS to BIM, it's possible with tools like the Onuma system to automate the process of collecting information. These are objects automatically generated from the SEPS output, even if a BIM template is not available. The designer can then rapidly move objects into position. From a technical perspective, this is trivial and takes about 10 minutes to accomplish. Even objects that are not in the SEPS output are available from the 1691 equipment list, which can be added into the space and then visualized on iPad applications like this. So even non-technical users can confirm the layout of spaces and equipment and create certainty and consistency in the decision-making process in a repeatable way. These types of tools are also available from many other vendors as well. Here is Revit with an export from the Onuma system in BIM XML that came from SEPS with the same equipment and spaces that a Revit user can also do the same exercise. Again, a very simple BIM process of just confirming, does this fit in the room and is this all the equipment that's required? And then showing that to the designers and subject matter experts for confirmation. The data then is automatically generated for lists of spaces and equipment. Here is SketchUp with the exact same process. Even within SketchUp, the same data that came from the Onuma system through SEPS now is visible as JSN objects, and the SketchUp user can run through the same exercise of moving equipment into position. Subject matter experts can then focus on decisions and not on the actual production of documents. The most valuable part of the effort is getting the subject matter experts' input into a process like this. Automatically creating a BIM from the SEPS BIM Excel export file. In the Onuma system, you log in and create a project and scheme, and then you select Add Scheme from the BIM requirement file and select the SEPS BIM Excel file provided to you. This will automatically generate a BIM using the latest BIM templates from VA, and it adds additional equipment or spaces that were edited inside SEPS. In other words, there's a one-to-one match from SEPS to this BIM. The designer can continue to edit and add or subtract or even create new spaces and add new equipment and lay out the spaces based on the requirements from SEPS. All of the data can make its way into the BIM, including into the Onuma BIM iPad application. So the actual data from SEPS, thousands of rows of code, are automatically generated in this BIM. Of the approximately 2,000 medical equipment pieces that are in the 1691 database, there are equivalent BIM objects that have been cataloged. These are about 800 in the beginning of 2015 and are going to grow over the year as new objects are added from consultants as they do their work. These are in Revit format, and they also are available as download links from this directory based on JSN and objects. So you can actually search within the web browser. You can search for example, finding a chair or whatever, and find that object download as an individual family in Revit and use that. These objects have also been incorporated into the Onuma system, so an Onuma system user can actually scroll through and find objects from the 1691 based on the JSNs and place them into a BIM within the interface. And they also have been picked up by a 3D warehouse as SketchUp objects. So SketchUp users can actually get the 800 objects either by visually looking at them like this or searching for, like, for example, D3320 would bring up a search which brings up the dental chair and then is available for download. SEPS data to BIM through the Onuma system and into Revit. Earlier, we imported the SEPS BIM Excel file into Onuma system and created these template spaces and equipment. Now we're going to export from the Onuma system into Revit using the export BIM XML file for Revit. Other BIM export options are also available. In Revit, using the free Onuma plugin, we go into Import BIM XML file and grab the BIM XML file that was exported from Onuma, include components, which will create the equipment, and select Import. Depending on the file size and the processing power of your computer, the import time will vary. Once it's imported, you will see a floor plan. In that floor plan, you'll see the spaces and equipment that were in Onuma, that were imported from SEPS, and any edits that happened in Onuma as well. In Revit, you select the visibility and turn off the equipment space option. It turns off the bounding box, and you get the resulting 3D view in Revit with the same equipment that came from SEPS into Onuma. SEPS to Onuma SketchUp for creating PG 1812 documents for the VA TIL. In the Onuma system, here we are looking at a group of spaces from SEPS with equipment in it. We're going to export to SketchUp as a BIM XML file. It's the same export as what would go out to Revit. In SketchUp, with the Onuma plugin for SketchUp, as you import the XML file, what SketchUp does is it goes to the 3D warehouse of 1691 objects and finds the associated objects that's coming out of SEPS and places it, actually downloads it from the warehouse and places it into this SketchUp file. It automatically places it in the correct location based on what was in the SEPS BIM templates, correct height, and the correct objects. If an object is missing, red bounding box is placed in the model. This red bounding box is the right dimension based on the JSN 1691 data from the MIL standard 1691. So it's still usable, it's just that it doesn't have a detailed 3D model of it. The user can then open up the SketchUp model and continue to design with this automatically generated version of the BIM template. From there, in SketchUp, for example, you can continue to label the objects. Objects actually have the correct JSN number and information attached to them, attributes that came from SEPS and the 1691 inside the objects inside SketchUp. So in SketchUp, you can continue to label these objects. Notice that the parameters and p-sets are actually there. And from here, you can actually then even generate the PG 1812 type document with floor plans, isometrics, and elevations generated from the SketchUp objects that came from the SEPS to BIM process.